students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as correlation and regression. Let's see this. Find rank correlation. The data given to you is R1 is given to you as 357 12864. And rank 2 is given to you as 214 5763 8. Right? The first thing that you do is you find out difference. How do you find out difference? Difference is R1 minus R2. 4, 3, minus 4, minus 5, 2, 3 and minus 4. Then you find out D square. 1, 16, 9, 16, 25, 4, 9, 16. Add this. This is called as sigma D square. So when you add this, you will get this addition as 96. When you want to find out rank correlation is given by the formula Spearman's rank correlation is given by the formula 1 minus 6 times sigma D square upon n square minus 1. So 1 minus 6 into 96 upon n is the number of terms. 1, 2, 3, 4, 5, 6, 7, 8. 8, 64 minus 1. So in that case, when you solve this, you will get this answer as 1 minus 576 upon 8 into 63. Right, so this will be 1 minus 576 upon 504. The answer will be negative 0.1429. So the rank correlation is negative 1429. Right, take on next one please. Find rank correlation for the following data. Find rank correlation for the following data. 45, 56, 54, 39, 36, 30, 60, 62, 48, 50. Right? 40, 42, 50, 40, 42, 50, 30, 36, 20, 45, 39, 44, 32. Now in the previous some ranks were given to you. Here ranks are not given to you. When ranks are not given to you, first you have to get the ranks. How do you get the ranks? Look at your X column. Whichever is the largest number, you will give it the first rank. The largest number is 62. Then the number close to that 60. The number close to that 56. The number close to that 54. The number close to that 50. The number close to that 48. The number close to that, this is the sixth rank. The number close to that 57. The number close to that 45, and after that 8th, 9th and 10th. This is how you give the rank. So I have done this for X. Now the same thing you will do for Y also. The largest number you will give it as the first rank. Right? Your largest number is going to be 50. The number closest to 50 is 44. No, 45. So 45 will be second rank. 44 will be third rank. Fourth rank. Fifth rank. Sixth rank. Seventh rank. No, 7th. 8th rank. 9th rank and 10th rank. Once you have the ranks, then it is like the previous sum. First thing that you do is you find out difference. 5 minus 1. How do I find out difference? Difference is R1 minus R2. Right? 3 minus 1. 2, 0, 0, minus 5, 3, minus 3. Then you find out d square, 4191, 400, 2599, right? And then you use your formula. How do I solve that? This can be solved using the formula Spearman's rank correlation is R is equal to 1 minus 6 times sigma d square upon n square minus 1. You can substitute your values and get the answer. The answer for this should come out to 0.6242. Fine, do we get this thing here? Next, let's see another sum of this kind, guys. Find rank correlation, right? X, Y. I'm giving you some for practice: 23, 27, 28, 29, 30, 31, 33, 35, 36, 39. Then 18, 22, 23, 24, 25, 26, 28, 29, 28, 29, 30, 32. Right? So that's your data given to you. You have data, you can easily find out rank correlation. It's like your second sum. First you rank the data and then you find rank correlation for this. You should get the answer for this as rank correlation answer R should be equal to 1. Right? Next, let's see another sum. Find rank correlation R1 and R2. Here they have directly given you ranks 6431, 6431, 2798, 2798, 105, 1467, 5810, 32. Ranks are given to you. You have to find rank correlation. This is like your first sum, right? It's exactly like your first sum. Solve this exactly like your first sum. You should get the answer for this as answer for this sum should be R is equal to 0.1515. Next, let's see another sum. Find rank correlation. Rank correlation is X and Y, 1.5, 3, 2, 2.5 and 1. This is 8, 7.2, 9.3, 6.5 and 7.1. Again, here you have to first rank the data and then you will have to get the rank correlation. This will be like your second sum where you rank the data first and then you get your rank correlation. The answer for this should be R is equal to -1. Next, let's see another sum of this kind. X, find rank correlation. Rank correlation. Rank correlation X and Y. This is 32, 25, 15, 27, 8, 16, 18, 12. Next, you have 15, 18, 22, 17, 16, 20, 10 and 13. Again, like the second sum, you have to find rank correlation for this data. right? You should be able to get this, rank the data, and then you get your rank correlation for that. The answer for this should be answer R is equal to negative 0.0476. That is going to be my rank correlation for the data. Next, let's see another sum. Find rank correlation. Right, I'll do the sum. Data is 35, 42, 35, 42, 15, 38, 35, 25, y, 12, 18, 17, 19, 18, 20. Right? Now first let's rank the data. Right? The largest number here in this is going to be in X column is 38. No, largest number is 42. So in that case, I will say that 42 will get first rank. Then the number closest to that is 38, second rank. Now we have a problem. The number closest to that is 35 and there are two 35s. Right? There are two 35s, one here and one here. Now ideally if these two numbers were not the same, they would have been given third and fourth rank. In that case the rank that you will give both of them will be the average of that. That means 3 plus 4 divided by 2, they will be given rank 3.5. Both of them will be given same rank and that rank will be the average of the two numbers. Right? So they will be given rank 3.5. Ideally they should have been given rank 3 and 4. So what you do is whatever rank they had to be given, find the average of that. 3 plus 4 divided by 2, that gives you 3.5. So third and fourth rank is gone. Then this will be fifth and this will be sixth rank. Next, let's see this. The largest number here is 20. First rank, 19. Second rank, 18. There are two 18s, right? So they should have been given third and fourth rank. So 3 plus 4 divided by 2, 3.5. So these are going to be given rank 3.5 and 3.5. So third and fourth rank is gone. This will be fifth and this will be sixth. Right? Then you find out your difference. Difference is nothing but R1 minus R2. So this is 3.5 minus 6, negative 0.25. This is again negative 0.25. This is 1 minus 3.5.
Minus 2.5.
Right? Negative 2.5. Right? Then this is 1, this is 0, this is 0 and this is 5 minus 1 is 4. Then you find out d square. This will be 6.25, 6.25, 1, 0, 0 and 16. Add this. When you add this, you will get this answer as right, 6 and 6, 12, 29.5, right? Now, once you have this, then you can say, right? Once you have this, then you can say that sigma d square is 29.5. Now, when you have repeated ranks, you have to make a repeated rank table. Right? Which are the ranks repeated in the X column? Ranks which are repeated is 3.5. In the Y column also the rank 3.5 is repeated. Right? How many times has it been repeated? Twice and twice. In the X column it has been repeated twice, Y column has been repeated twice. Then you find out n square, 4 and 4, n square minus 1, 3 and 3, n into n square minus 1, 6 and 6, n into n square minus 1 divided by 12, 0.5 and 0.5. Right? N, first you find out n square, then you find out n square minus 1, n into n square minus 1 and n into n square minus 1 upon 12, 1. This number is called as correction factor. right? Whenever you have repeated ranks, your rank correlations, P1's rank correlation will be given by the formula R is equal to 1 minus 6 times sigma d square plus sigma correction factor upon n square minus 1. Right? Do you get this in here? So in that case, this will be 1 minus 6 times sigma d square, 29.5 plus 1 upon n. N is number of terms. Number of terms you have is 1, 2, 3, 4, 5, 6. 6 terms. 36 minus 1. Solve the equation. When you solve the equation, you will get the answer for this. 0.2143. Right? Next. Click on next up. Right? Find rank correlation for the following data. Find rank correlation for the following data. Find rank correlation for the following data. 50, 60, 65, 70, 75, 40, 70, 80. 80, 71, 60, 75, 90, 82, 70, 50. Here you are going to have repeated ranks. I want you all to try this on your own and see how you get this answer. You should get the,
We will have to find a repeated rank table for both.
Yeah, for both. Wherever you have repeated rank, you have to find out both, in the sense there will be only one table. You take the numbers from X column as well as, that is D1, R1 column and R2 column, right? The answer for this should be negative 0.3571, right? Next, take on another sum, guys. Find rank correlation X, Y, 67, 48, 53, 67, 62, 60, 56, 69, 78, 80, 78, 75, 73, 76, 68, 63. Answer for this sum should be negative 0.5654. Right, that should be your rank correlation. Again, here you have repeated ranks, so you will have to make repeated rank table. Right, do you get this in here? Next, let's see this. Take down. The rank correlation was found out to be 0.667, and the sum of the squares of the ranks, sum of the squares of the difference in the ranks, the sum of the squares of the difference in the ranks was 55. Find the number of observations. Find the number of observations. Find the number of observations. Now we know that R is equal to 1 minus 6 times sigma d square upon n square minus 1. So 0.667 is 1 minus 6 times 55 upon n square minus 1. Take this on the other side, 6 into 55 upon n square minus 1 is 1 minus 0.667. So in that case, 6 into 55 upon n square minus 1 is nothing but 0.333, right? In that case, 6 into 55 upon 0.333 is equal to n square minus 1. When you divide this, you should get this answer as 990. Therefore, I can say that n into n square minus 1 is 990, right? 990 can be written as n into n square minus 1 is nothing but 9 into or 10 into 99, right? This can be written as 10. 99 can be written as 100 minus 1. 100 can be written as 10 square minus 1. This is in the form n square minus 1. Both the sides are in the form n square minus 1. Therefore, n should be equal to 10. Right? That finishes that sum. We'll stop this here for the day. Thank you very much.